Hello, today's tutorial is about, it's a two-part series, and this is basically on a breakout board um, that is a USB to a human interface device or HID device. These are keyboards and mouse, so you can send via USB port um, commands that will appear to the other computer as a keyboard or a mouse. The chip used for doing that translation is CH9329, and it's available on the internet. Uh, and you can order it through Alibaba Express. We'll look at it where you get those. So let's get started. This is one side of the chip. As you can see, a lot of Chinese. Actually, this was hard to find a lot of information on the internet. But I'll show you stepwise how to program it, how to run a little Python program in order to send the USB commands so that we can control another computer using a Python program running in a different computer. This is the picture of the top of the board. You can see CH9329 chip over here. You can see some wires going from this particular chip, which is USB to UART converter. So your computer, the host computer, hooks up here, and the USB port appears as a COM port. You send commands through this, which are converted to serial commands and fed into this particular chip, which converts that into HID keyboard and mouse commands and send it out to the other computer that's hooked up on this side. This is the structure of a simple diagram that shows you a master computer, as I explained, send USB commands through this chipset, converts it to USB UART, and then those are fed into a serial command into CH9329 chip and to the slave computer, which will receive those as keyboard or mouse commands. Actually, this chipset has ways to program it so that you can configure any HID device, not only keyboard and mouse, but other HID devices as well. Where you can buy it, you can buy this from Alibaba. Here is the link to Alibaba, and I'll post a link on the comments below, details below the video as well. It's a $10 chip, but remember that it will take a little while before it arrives because it is shipped directly from China. Let's get started to look at some of the commands. The information mostly available for the chip are very difficult to get. Number one, there's no English manual available. All the Chinese manual that I have to kind of decipher to extract some key information to prepare for the demo. So the command structure looks like this. The USB commands are sent through a Python program, which we will demo in the part second of the series. This is the structure, a general structure of the commands that can be fed into the breakout board. So the header bytes are 2 bytes. It is 570A. Almost always these 2 bytes are same value. And then the address byte is also 00. So just make these constants. Anytime you send the command, these 3 bytes are always there. Then the command code, the fourth byte here is the code for the command that you're going to send. The keyboard command is a different code, mouse command is different, so on and so forth. Then you send the length of the number of bytes of data that you will send after this. So if there are 5 bytes of data, you will put a 5 over here. That is followed by the number of data bytes. So as many bytes you specify over here, you will send the data bytes, and those are also specific to the particular command code. We'll look at two of those in the slide to follow. Then there's a checksum byte. Checksum is actually sum of all of these bytes divided by 100, 0x 100, and the remainder of that is the checksum. You can write a simple function that can calculate the checksum for all of this and add it at the end of the buffer of the command. Let's look at two of these commands that I will show you in this slide. The first one is the keyboard command. As you know, the header byte, the address, the command code for the keyboard command is 02. Then you specify an 8 for 8 bytes of data, followed by 8 individual bytes of the data that is related to this command. Here are the definitions of these bytes. The first byte is a control keyboard. So the control keys are, this is expanded over here. This byte specifies the modifier keys or the control keys. The left and the right shift key, for example, control key, alt key, window key, all of these, when pressed, you can specify the by raising one of those bits in this control byte to specify which key is pressed during the sending of the command. Followed by byte 2, which is always 0. And then from byte 3 to byte 8, you have 6 consecutive key presses that you can send. So you can send multiple key presses with this command as well. So this is the structure. We'll look at it in a Python program in the part 2 of the series. Let's look at the mouse command. Again, the header bytes are same, the address byte, the command is 05 for this one, and we're going to send 5 bytes of data, and that's why the length is 5. Again, checksum is the same. So general structure. Then these 5 bytes of data are detailed below here. The first byte is 0x1 always. Byte 2 will tell you the button press status of the mouse. So if the center mouse is pressed, this bit will be up. If right button is pressed, this bit will be up. And if left button is pressed, bit 0 will be up. So this byte will specify what button press is there for the mouse. Then you will specify byte 3, byte 4, byte 5 is X move, Y move, number of pixels of the mouse move to the right, to the left, and then the wheel move. So there are some restrictions, and we will look at it how these restrictions apply to this command. And also note that this mouse command is for relative movement of mouse, not absolute movement of the position. So the mouse will not jump to a position, but it will specify how many, if the mouse is positioned at this point, then it will specify the differential of how the mouse is moved to a new position. In the next part of this series, we will take a look at a little Python program that will utilize this knowledge to send the commands to a Ubuntu computer that I have set up.